second installment of video lessons for you. In the first lesson, we talked about the steps of the scientific method. So we went over the fact that first we make an observation, and then from that observation we develop a question. And then from that question, then we develop a hypothesis or an answer to that question. Then we'll test our hypothesis, we'll analyze the data, and then we'll come up with conclusions. Well, one part that I didn't talk a lot about was the experimentation part of it, or how to set up and run a good experiment. So this right here is part 2, scientific experimentation. In this lesson, we're going to talk about how to run a good experiment. So, scientific experiments. Scientific experiments are set up in a way so that they can do a couple things. First off, they need to be repeatable. So if we've come up with something amazing, if we solve one of the great mysteries of the world doing a scientific experiment, other scientists need to be able to repeat it to test to make sure that we did it right and to make sure that what we're actually claiming is true. So they have to be repeatable, and they need to have some things in order to be good experiments. The first thing that they need to have is a control. And we'll go into what these are in detail. The second thing they need to have is controlled variables. And the third thing they need to have is it needs to be reproducible again. Other scientists need to be able to reproduce our experiments. So let's talk a little bit first about variables and what variables are and how they work. A variable is something that can cause an experiment or the results of that experiment to change or to be different. So variables are things in an experiment that can change. Okay? There are a bunch of different types of variables. There are 3 of them. There are what we call the independent variable, the dependent variable, and then controlled variables. Okay, the independent variable. The independent variable is, up here it says, the factors that are changed by the experimenter, so by the scientist, to produce a result. What that means is this. The independent variable is the thing that I, the scientist, am changing. And most of the time, it's the thing that I, the scientist, am testing. For instance, if I'm going to test which brand of toothpaste is the best. So if I'm going to check to see if my brand that I just created is better than another brand, the independent variable is the thing that I'm testing. In this case, it's going to be the brand of toothpaste. So the thing that I'm changing in the experiment. So I'm giving one person one brand of toothpaste, and I'm giving another person another brand of toothpaste. Therefore, the independent variable is going to be the brand of toothpaste. It's the thing that I, the scientist, am changing. Okay? Question to ask is, what do I change? That answer will give you the independent variable. The next, the dependent variable, is the thing that changes in response to the independent variable. So this would be, say for instance, in our toothpaste experiment. So if we're going to change brands of toothpaste, if I'm going to give one person brand A and one person brand B, the thing that's going to change in response to that maybe is the number of cavities those people get. So maybe we'll count cavities and we'll just see how many cavities you have. And that's going to end up being our dependent variable, what changes in response to. And a lot of times we can figure this out by answering the question, what do I observe? So if I'm observing, if we're changing toothpaste, but what I'm actually observing is the number of cavities, that is going to end up being our dependent variable. The last type of variable are controlled variables. And control variables are things in an experiment that we need to make sure to keep the same. Things that we don't want to test for. For instance, if we have 2 people and we're testing toothpaste, and one eats nothing but sugar for a month, and the other one eats vegetables for a month, that could have an effect. The one that's going to eat only sugar is going to have more cavities than the one that eats only vegetables. So in that experiment, that's a variable that we need to control. We're going to have to make sure that they eat the same meals. Or maybe one of them brushes with brand A 8 times a day, and one of them brushes once a day for 2 seconds. Well, that's going to have an effect. So the amount of time they brush has to be the same. So those are what we call controlled variables. They're not what we're testing, but they have to be the same in the experiment. Great way to look at this is to answer the question, what do I keep the same? Okay? So, if we're looking at controlled experiments, so our experiments, they need to have variables, and they also need to be controlled. And how we do that is we actually carry out two separate experiments side by side. In one group, we're going to use the independent variable, and in the other group, the one that we use the independent variable in is what we call the experimental group. So the group that we're actually testing on is the experimental group. For instance, if we're using the toothpaste on somebody, we're going to use the experiment. That would be our experimental group. And then in one group, we're not using the independent variable. So for instance, if I want to test to see if a toothpaste reduces the number of cavities, then in one group, I'm going to give the toothpaste to, and that's going to be my experimental group. And maybe the other group, the one that I'm not giving toothpaste to, maybe they just brush with water for a month. And then we can count the number of cavities. So we can say, oh, the one that brushed with toothpaste had way fewer cavities than the group that brushed with only water or that didn't brush their teeth. Kind of a gross experiment. Maybe some ethical considerations there of making people not brush their teeth for a month, but that's how we explain the groups. So the one that we're using the independent variable, experiment. The one that's not getting the independent variable is a control group. Experiments need to have control groups. So when you design experiments, your experiment has to have a control group. The important part about a control group is a control group allows us to compare. We have no idea if our toothpaste works unless we have something to compare it to. Without a control, we can't compare. Alright, another type of experiment, we'll talk just briefly about this, is a natural experiment. So sometimes life is not as easy as a lab experiment, or sometimes we can't do lab experiments. For instance, if I'm going to go out and I'm going to observe a population of deer, I'm not going to be able to bring that population into my lab most of the time. Or if I'm going to observe mating behaviors of deer, I'm not going to be able to bring those deer into my lab. So we can't have a controlled experiment. And a lot of times in these natural experiments, they're just observations of the world around us. So it's a scientist going out in the field, observing populations of deer, taking very close data. A lot of times when we look at fish populations or animal populations, they end up being natural experiments. Field experiments fit into that one. Okay, let's talk. We have two little things we're going to talk about next. Let's talk about error. So why does error result in an experiment? And the answer to that is error can occur when the experiment is neither accurate nor precise. So if our experiment is not accurate or precise, we're going to end up with error. And these two terms I want you to know. The first one is accuracy. How close the measurement is to the actual value. So, for instance, if we look at this left bullseye here, we have a whole bunch of bullet holes. We can call them bullet holes, and they are fairly close to the center of the circle. So those bullet holes are accurate. Okay? These ones over here, we have a bunch of bullet holes that are further away from the center, and those we would call less accurate. Those are not very accurate shots, or in our case, they're not very accurate measurements. If we're measuring a block, and that block is 5 centimeters, and we get 3 centimeters, that's not a very accurate measurement. If we get 5 centimeters right on the button, that would be an accurate measurement. Precision's a little different. This is how close together the measurements are. This group over here, this target to the left, has accurate but not precise measurements. Or accurate but not precise shots. So the bullets are not close together at all, but they're all close, relatively close to the center. This one over here is precise. All the bullets are very close together, but it's not accurate. So if we're going to measure a block that's 3 centimeters, if we have something that's precise but not accurate, each time we measure it, every single time we do it, maybe we measure 2 centimeters. We're not accurate, we're not getting correct measurements, but we're getting precision. We're measuring it close every time, our measurements are close together. Okay? Last thing I want to talk about is a theory. Scientists use this word very differently than people. A lot of times you hear the phrase, oh, it's just a theory. This word is used in our language as just a guess. Oh, it's just a guess. It's just a theory. A scientific theory is not a guess. A scientific theory is a hypothesis that has stood up to repeated testing. So this is a hypothesis that has been tested over and over and over and over again and never proven false. An example of that is evolution. You hear evolution being talked of as just a theory. It's just a guess. It's just what Darwin thought. Right now, evolution is a hypothesis that has never, ever, 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 ever been tested false, scientifically. That's the meaning of theory. A hypothesis that has been tested over and over again and has never been proven false. So make sure you keep that in mind. When people tell you evolution is just a theory, that should mean something different to you. Well, class, if you have any questions, you can ask me anytime. I am here for you. We'll talk about this when you get back to class tomorrow. So if you have any questions, let me know. Email me. I look forward to hearing from you. Have a good day, team.